The performance of industrial refrigeration control valves can be a critical factor in the safe and efficient operation of an industrial refrigeration plant. Industrial air units which do not defrost thoroughly can eventually build frost and operate inefficiently. Defrost sequences which do not adequately vent or equalize low temperature evaporators to house suction after defrost can shock or stress the suction line piping upon termination of a defrost cycle. These are but two of the many examples of where industrial refrigeration control valves are required to operate reliably, safely, and continuously. For proper performance, control valves must be chosen correctly, properly installed, and periodically serviced. Safety is always paramount when servicing any control valve. All personnel working on industrial refrigeration components must be qualified service technicians. Safety bulletins published on control valves should be thoroughly read and understood. Product bulletins covering specific valve types should be read prior to the service procedure in order that the operation of the valve in question is fully understood. Additionally, the knowledge of how a valve should work when applied and sized properly is critical to understanding why or how it failed. Finally, it is important to understand the nature of the control valve failure prior to bringing the valve back online. The valve serviced in the following tape is a refrigerating specialties type A4AB, an inlet pressure regulator with a wide opening or bypass feature. This valve regulates the back pressure with the solenoid coil de-energized, yet acts as a wide open solenoid with the coil energized. Pilot pressure is communicated through a small channel on the inlet side of the regulator to the pilot section of the valve. Once inside the adapter, this pilot pressure will be transmitted to one of two paths. With the pilot solenoid de-energized, pilot pressure is diverted through a moduplate, which directs the flow to the underside of the diaphragm. The valve then is in a regulating mode. With the pilot solenoid energized, pilot pressure takes a direct route through the solenoid to the top of the piston, bypassing the regulator pilot section. Pilot pressure works against the top of the valve's piston, imposing enough force to overcome the force of the valve's closing spring. The valve will then either regulate a back pressure or go to a wide open position, depending on whether the solenoid is energized or not. Most pilot-operated regulators require a minimum pressure drop across the valve, about 2 psi, to modulate or overcome the closing spring force.
In this tape, we will cover service of the A4AB 3/4 inch regulator, used as a discharge pressure regulator in this application. The first step in this procedure is to remove the seal cap from the pilot regulator portion of the valve. Next, remove the seal cap covering the manual opening stem. Using a refrigeration wrench, turn the stem on the pilot regulator counterclockwise. This will remove any previous set point. Use the refrigeration wrench on the manual opening stem, also turning counterclockwise. Isolation and evacuation. First, isolate the valve upstream of the control valve being serviced. Tag the valve for safety and unauthorized operation. This is an example of a lockout tag available from Parker Hannifin. Next, close the hand valve downstream of the control valve being serviced. And again, apply a lockout tag. Use the procedure in place at your facility for tagging hand valves. We now need to find a point on the isolated section that we can purge the trapped refrigerant. This is usually a gauge valve. After closing the valve, we next need to find a place to attach a purge line. In our test system, we've installed a T in between the gauge valve and the gauge. This allows us to leave the gauge on for illustrative purposes. Turning the pipe plug slowly counterclockwise allows us to vent any trapped refrigerant between the gauge and gauge valve. Now we can safely remove the pipe plug and attach either a purge line or fitting to attach a purge line to. Please note, this is a test system, so piping configuration and procedure may vary. Now attach the purge line to the access fitting. Place the other end of the line into a bucket of cool, clean water. Now open the gauge valve slowly. Purging. Continue this procedure until bubbles are no longer produced. Servicing. De-energize coil. The first step in this procedure is to remove the stainless steel coil assembly hold-down screw. Now remove the coil from the solenoid tube. Verify that power has been removed by inserting a screwdriver in the bottom of the coil. If the screwdriver is drawn to the coil, power has not yet been removed. Using an 1.5-inch wrench, remove the solenoid tube nut. Now, lift the tube from the assembly. This will expose the solenoid plunger. Inspect the tube and plunger assembly for wear and other foreign materials that may prevent the solenoid from operating properly. Now, using a 7/16 wrench, remove the 4 screws that hold the solenoid body to the adapter. Be careful not to lose the O-rings. Inspect the seat area for any wear. Now, with a 1/2-inch wrench, remove the 8 bolts that hold the pilot regulator bonnet to the adapter. Use a screwdriver to pry the bonnet from the adapter. Lift the bonnet straight up. Make note of the stack up of the spring rest, and diaphragm follower. Now, using a 1/2-inch wrench, remove the 8 screws that hold the adapter to the main valve body. Again, using a screwdriver, pry the adapter from the body. Next, we need to remove the diaphragm. This can be done with a small screwdriver. Place the blade of the screwdriver on a small flat on the circumference of the diaphragm. Twisting the screwdriver will break the diaphragm free of the gasket inserted below. Inspect the pilot seat. Inspect the diaphragm for cracks, nicks, or anything else that would impede its performance. Next, using a 1/4 20 screw, insert it in the top of the piston and remove the piston from the valve body. Inspect the piston for any signs of wear. Make sure the bleed orifice is free of dirt. Now we need to remove the bottom cap from the valve body. This can be done by using a large wrench and turning the cap counterclockwise. After it's broken loose, this cap can be removed by hand. Next, we will remove and inspect the modulating plug and manual opening stem. Using a 7/16 wrench, remove the packing nut. Now, using the refrigeration wrench, turn the manual adjusting stem clockwise until you can no longer turn the stem with the wrench. Push the stem through the bottom cap and pull the plug from the bottom cap assembly. Now let's remove the spring and spring washer. This is done by pulling back at the spring and removing the nylon retaining ring. Now you can remove the spring and spring washer from the plug and stem assembly. Inspect all the components. Look for wear or signs of wire drawing. This video illustrates the effects of wire drawing. Reassembly. We can now start the reassembly procedure. Taking the spring, place it on the modulating plug and compress it with one hand while pulling the stem forward with the other. Place the spring washer on the stem. Now reassemble the retaining ring. Now we're ready to place the assembly into the bottom cap. Push until the stem is visible through the packing. Taking your refrigeration wrench and keeping pressure applied to the modulating plug, turn the stem counterclockwise. Now replace the packing nut and tighten with a wrench. Next, using the refrigeration wrench, turn the stem clockwise until the flats of the stem are even with the packing nut. Inspect the O-ring for tears. Make sure the plug moves freely in the assembly. Now let's remove any leftover gasket material. We can now reassemble the bottom cap and modulating plug into the main valve body. Turning the plug clockwise with hand at first, and snugging it with a wrench. Remember, this is an O-ring seal and over-torquing is not necessary. Next, inspect the piston for any scratches or unusual wear and reassemble in the valve body. Make sure it moves freely. Now we're going to install the body to adapter gasket. It is important that the pilot hole in the gasket and body line up. Now remove the old body to adapter gasket. Remove the lower diaphragm gasket. Again, check the seat for any wear. Reassemble the adapter to the body, making sure the pilot hole lines up. Reinstall the 8 5/16/18 screws that hold the adapter to the body. Tighten with a 1/2-inch wrench using a crisscross pattern. Now let's install the diaphragm gasket. The largest cross-section gasket is the first one to be installed. Now wipe clean and inspect the diaphragm for nicks or scratches. If any are found, replace with a new diaphragm. Reassemble the diaphragm in the adapter. We can now install the smaller cross-section gasket above the diaphragm. Next, the diaphragm follower. Inspect for any scratches or unusual wear. The lower spring rest. The spring and upper spring rest. Again, scrape off old gasket material. We can now reassemble the bonnet on the adapter. And replace 8 5/16/18 screws. Using a 1/2-inch wrench, tighten the bolts in a crisscross pattern. Moving ahead, we can now reassemble the B-feature solenoid body. Inspect the Teplan seat for any nicks. If damaged, this seat should be replaced. Make sure the 2 O-rings are in place. Now we can reassemble the solenoid body to the adapter using the 1/4-20 screws. Tighten the screws using a crisscross pattern. Next, we'll install the solenoid plunger and needle assembly. Make sure the needle is not damaged. Insert the plunger needle side down. Now let's reinstall the solenoid tube. Replace the aluminum gasket with a new one. Place the solenoid tube over the plunger assembly. Next, replace the solenoid tube nut and snug by hand. Then tighten with an 1.5-inch box wrench. Now replace the solenoid coil assembly. Install the stainless steel hold-down screw. Make certain this is the screw supplied with the valve. Any other screw may cause improper operation of the solenoid. Tighten with a screwdriver. After pulling a vacuum on the isolated section, remove the purge line. Remove the access fitting and replace the pipe plug. Using a refrigeration wrench, open the gauge valve to put the gauge back in service. Make sure the valve is in the automatic position. Replace the seal cap. Snug with a wrench. Now remove the lockout tag from either of the 2 hand valves. Crack open slightly to pressurize the serviced valve. Using a sulfur stick or any other form of leak detection, check for leaks. Now open the hand valve fully. Now remove the remaining lockout tag and open the hand valve fully. The system can now be restarted. Remember, it has been off during this procedure due to the fact this is a discharge control valve. Now it's time to put a set point on the newly rebuilt valve. Turning the stem clockwise will increase the holdback pressure. It's a good idea to adjust the valve slightly above and then back to the desired set point. This ensures a good setting. After the valve is set, replace the seal cap. And snug with a wrench. This concludes the servicing of the A4AB regulator.